Your swing arm has a number on it. You set your tires to that number. Every rider you have ever met sets their tires to that number. It is stamped into metal on the machine itself, permanent, official, from the factory. That number is not wrong. It is also not the number that will get the most out of your tires, your handling, your fuel economy, or your safety in every condition you actually ride in. There are 3 PSI numbers connected to every motorcycle tire. The swing arm tag is one of them. Your owner's manual may list a different one. The sidewall of the tire itself has a third. Most riders have never looked at all 3 simultaneously. Most riders have never understood the difference between what each number means, who said it, and why they said it at that figure rather than a different one. When those 3 numbers do not agree, and they frequently do not, most riders follow the swing arm tag by default because it is the most visible number in the most authoritative location on the machine. The result is a specific and documented pattern of premature tire wear, degraded handling, reduced grip in wet conditions, and fuel economy losses that compound across every mile ridden. I'm Jimmy. This video covers every variable that determines the correct tire pressure for your motorcycle. Not a single number, not a shortcut. The full picture, because a car with wrong tire pressure handles differently, and a motorcycle with wrong tire pressure can put you on the ground. The swing arm tag number is set by the motorcycle manufacturer. It is chosen to produce a specific combination of outcomes across the widest possible range of riders, loads, road surfaces, and temperatures that the manufacturer anticipates the machine will encounter. That means the swing arm number is a compromise, not a carefully tuned optimization for your weight, your typical load, your riding style, and the roads in your specific region. A compromise that serves the median expectation across everyone who might ever own that machine. The specific variables the manufacturer must accommodate simultaneously are significant. A machine may be ridden by a 140-pound person with no luggage or a 240-pound person with a full passenger and loaded panniers. The swing arm number cannot be correct for both simultaneously in any meaningful engineering sense. The manufacturer chooses a pressure that is acceptable for both, which means it is optimized for neither. The owner's manual number may differ from the swing arm tag for a specific reason. Most owners' manuals list multiple pressure recommendations: solo riding, 2-up riding, and sometimes fully loaded touring configuration. The swing arm tag, limited by the physical space available to stamp information, typically lists the solo or minimum specification. The manual's loaded specification can be 4 to 8 PSY higher on the rear tire for machines designed for 2-up or cargo use. Riders who never open the manual and follow the swing arm tag while riding 2-up are running chronically underinflated rear tires for that load condition. The consequences are documented: accelerated wear on the outer edges of the rear tire, reduced handling precision in cornering under load, and increased heat generation in the tire structure during sustained riding. The sidewall maximum PSY is the number most misunderstood. The max PSY on the tire sidewall is not a target. It is a structural limit, the maximum pressure the tire's casing can safely contain at maximum rated load. Running at or near max PSY for normal street riding produces the opposite problems from underinflation: accelerated center tread wear, a harder contact patch with reduced grip, and a harsher ride that transmits more road shock through the chassis. The sidewall max is the ceiling of a range. The swing arm number is the floor of acceptable performance across a wide range of conditions. Your correct pressure lives somewhere between them, and where exactly depends on variables that no stamped metal tag can encode. A motorcycle has 2 tires. Each tire has one contact patch. Those two contact patches, each approximately the size of a credit card on a standard street bike, are the only points of contact between the machine and the road. Everything that keeps you upright, allows you to steer, enables you to stop, and determines how the machine behaves in a corner happens through those two patches of rubber. Not through the chassis, not through the suspension, not through the frame. The contact patches. Tire pressure determines the size, shape, and stiffness of those contact patches more than any other single variable you can adjust without tools. Overinflated tires produce a contact patch that is too small and located primarily at the center of the tread. The tire is effectively riding on a narrow strip rather than across its full tread width. The result is visible in wear patterns: a bald center strip with significant tread remaining on the edges, and in handling behavior: reduced cornering grip, lighter steering feel that can transition to understeer, and reduced braking traction in a straight line. Underinflated tires produce a contact patch that is too large and deformed. The tire deflects excessively under load, causing the contact patch to spread toward the edges of the tread in ways the tire was not designed to accommodate. The result is accelerated edge wear, excessive heat generation as the tire flexes beyond its design parameters, and a specific instability in straight-line tracking that riders sometimes mistake for wheel balance issues or steering head bearing wear. The correct inflation produces a contact patch of the size and shape the tire engineer intended when designing the compound, construction, and tread pattern. That contact patch, properly formed, delivers the grip, wear characteristics, and handling behavior the tire was designed to provide. The way to verify your contact patch is correct, a technique that experienced riders and race tire engineers have used for decades, requires nothing more than chalk and a flat piece of pavement. Draw a chalk line across the full width of your tires from edge to edge. Ride a short distance at normal speed, make a gentle lean from side to side, and park. Look at where the chalk has transferred from the tire to the pavement. Even chalk transfer across the full tread width indicates a correct contact patch. Chalk transfer concentrated at the center indicates overinflation. Chalk transfer concentrated at the edges indicates underinflation. This test costs nothing. It tells you more about your actual tire performance than any gauge reading in isolation. Every tire pressure conversation that does not include temperature is incomplete, and most of them are incomplete. Tire pressure changes with temperature. This is basic physics. The ideal gas law, which states that as temperature increases, pressure in a fixed volume increases proportionally. For motorcycle tires, this relationship has specific and practical consequences. At ambient temperature, a motorcycle tire set to 36 PS1 cold will reach approximately 39 to 42 PSY after 30 minutes of highway riding in summer conditions. The exact increase depends on ambient temperature, road surface temperature, riding speed, and tire compound hardness. As a practical working estimate, a tire gains approximately 3 to 5 PSY during normal street riding once fully warmed. This is why the instruction to check tire pressure cold is universal, not as a preference, because it is the only measurement that is reproducible and comparable. A cold tire, meaning a tire that has not been ridden on for at least 3 hours, is at a known temperature baseline, approximately ambient air temperature. A tire that has been ridden for any significant distance is at a temperature that varies based on conditions you cannot precisely control. Checking and adjusting pressure on a warm tire produces a reading that means nothing in isolation. The practical consequence for motorcyclists: check pressure before the first ride of the day, before the tire has been warmed. If you commute to work and want to check your pressure when you arrive, the reading is not reliable for adjustment purposes. It has already risen 3 to 5 psi from the cold setting. If you let air out to bring a warm tire to the swing arm number, you have set your cold pressure 3 to 5 ps below the swing arm recommendation, which is meaningfully underinflated for normal riding. 2 additional temperature variables that most tire pressure content ignores. First, seasonal adjustment. A tire set to the correct cold pressure in summer will measure lower in winter by a predictable amount. For every 10 degrees Fahrenheit of ambient temperature drop, tire pressure decreases by approximately 1 psi. A tire set to 36 ps1 in August will measure approximately 33 ps1 in December if the ambient temperature has dropped 30 degrees. Riders who set their pressure once in spring and never recheck through winter are running progressively underinflated tires as the season changes. Second, sun exposure. A tire sitting in direct sun on a hot day can reach surface temperatures significantly above ambient air temperature even before the motorcycle is ridden. Checking pressure on a tire that has been sitting in direct summer sun for an hour will give a reading that overstates the cold pressure. Check in shade, or wait until the tire has been shielded from direct sun for at least 30 minutes. The tire pressure situation is one part of a larger picture, the complete cost of ownership calculation that most motorcycle purchases never include. The 2026 Motorcycle Buyer's Bible documents in Section 2, the OEM tire compound issue. The tires on your new motorcycle from the factory use a fleet compound that wears 30 to 50% faster than the replacement market version of the same tire sold under the same name. Correct inflation helps. Starting with a correctly compounded tire helps more. Section 7 has the pre-purchase inspection checklist with the specific tire condition checks, date code, sidewall cracking, wear pattern reading, that tell you the true state of any used machine's tires before you agree to a price. Link in the description. Was $97, now $9. The swing arm pressure recommendation is typically set for a solo rider at normal road speed. What it cannot accommodate on a stamped metal tag is the full range of loads a motorcycle will actually carry. For every additional 100 pounds of load on a motorcycle, passenger weight, luggage, fuel, accessories, rear tire pressure typically requires an increase of 2 to 4 psi to maintain the correct contact patch and prevent the excess load from deflecting the tire beyond its design parameters. Your owner's manual usually documents this. The recommended rear tire pressure for solo riding and for two-up or loaded riding are often different specifications in the same document. A machine whose swing arm tag reads 36 rear PS5 for solo riding may specify 40 to 42 rear PS5 for two-up riding in the manual. The front tire specification changes less dramatically with load changes because the weight distribution shifts disproportionately to the rear when luggage and a passenger are added. The rider who memorizes the swing arm number and applies it regardless of load condition is running correct pressure only when the load matches the conditions the manufacturer used when setting that number. Every deviation from that specific load condition moves the tires away from their optimal inflation. The practical approach: know the solo specification and the loaded specification from your owner's manual. Keep both in your phone or written somewhere accessible. When your load changes significantly, adding a passenger, loading luggage for a trip, switching from commuting to touring, adjust rear pressure accordingly. This section requires the clearest statement in the entire video. Tire pressure management in wet conditions is not a comfort or economy question. It is a survival question. A motorcycle's 2 credit card-sized contact patches on wet pavement are operating at a fraction of their dry weather grip. The tread pattern exists to channel water away from the contact patch, to maintain rubber-to-road contact by displacing the water film that would otherwise sit between the tire and the surface. The geometry of that water displacement depends on the contact patch maintaining its designed size and shape. Wrong pressure changes the contact patch geometry and changes how effectively the tread channels water. Overinflated tires on wet roads reduce the contact patch size in a way that concentrates weight on a smaller area. In theory, this increases pounds per square inch at the contact patch. In practice, on a wet road surface, the reduced contact area means the tire has less rubber working to channel water away. The risk of aquaplaning, the tire lifting on a film of water rather than maintaining road contact, increases as the contact patch shrinks. Underinflated tires on wet roads produce a contact patch that spreads toward the edges of the tread in ways that distort the tread pattern geometry. The channels designed to displace water no longer operate at their designed angle and depth. The tire is physically capable of clearing water at the contact patch, but is not doing so efficiently because the contact patch deformation changes how the tread blocks engage the road surface. The experienced racing mechanic who served as a Continental Tire test rider makes a counterintuitive but technically correct observation about rain riding. At the limit of wet weather performance, a slightly higher pressure than the standard road pressure can reduce aquaplaning risk by maintaining a smaller, more concentrated contact patch that breaks through the water film rather than riding on top of it. This is not a recommendation for street riders to overinflate in the rain. It is a physics explanation of why professional rain tire setups sometimes run higher pressures than the same compound in dry conditions. For street riders in the rain, the practical instruction: use the correct pressure for your load and temperature conditions. Check it cold before you ride, and do not adjust warm tires in the rain because the reading will be misleading. This section requires you to physically look at 3 things on your motorcycle. If you have not done this in the last 6 months, do it this week. First, the swing arm tag. This is typically a decal on the swing arm, sometimes on the chain guard, sometimes on the frame near the rear wheel. It lists front and rear PSY, often with different specifications for solo and loaded conditions. Read both numbers. Note whether the loaded specification differs from the solo specification. Second, your owner's manual. Find the tire pressure section. It may list more conditions than the swing arm tag, different pressures for different loads, different speeds for specific tire types, or notes about the specific tires the motorcycle was designed around. If your manual lists a higher rear pressure for 2-up riding than the swing arm tag, that higher number is the one that protects your tire when you carry a passenger. Third, the tire sidewall. Find the maximum PSI stamp. Note it, not as a target pressure, but as the upper limit. You will never approach under normal street conditions. If your owner's manual specifies a loaded pressure that approaches the sidewall maximum on the specific aftermarket tire you have installed, you have a tire that may be undersized for the load the manufacturer intended the machine to carry. This is relevant when switching to aftermarket tires with different load ratings than the OEM specification. The following recommendations are derived from manufacturer specifications, tire manufacturer guidelines, and documented owner experience across each platform. They are starting points for verification with the chalk test and adjustment to your specific conditions, not universal prescriptions. Sport bikes, inline 4s, 600 cubic centimeters to 1,000 cubic centimeters. Most Japanese sport bikes in this category specify 36 PSY front, 42 PSI rear for solo street riding. The rear figure is higher than most riders expect and higher than most casual conversations about tire pressure suggest. The higher rear specification accommodates the performance demands the machine was designed for, acceleration loads, cornering loads, and braking loads that the rear tire manages in combination. Running a sport bike rear tire at 36 PSY instead of the specified 42 PSY for extended periods produces the specific wear pattern the manufacturer was trying to prevent with the higher specification. Rapid edge wear from an overlarge contact patch under cornering loads. Naked standards and middleweights, typically specified at 34 to 36 PSE front, 36 to 40 PSI rear, solo. The Z900 performance referenced in the comments section, factory specification of 42 PSY rear, is at the high end for this category, and the owner's experience of better handling at 36 PSY is consistent with a machine that specifies the loaded touring pressure as the base recommendation, which is common on machines with adjustable suspension designed for varied use. Cruisers and touring. Harley-Davidson touring machines typically specify 36 PSY front and 40 PSY rear for solo riding, with rear increasing to 40 to 42 PSY with a passenger. The Road King with the TPMS warning at 43 PSY referenced in the comments section reflects that the TPMS warning threshold is set above the recommended pressure, meaning the rider is already at correct pressure when the warning system first activates, not critically low. Understanding the warning threshold versus the optimal pressure is important on any machine with tire pressure monitoring. Adventure touring. ADV machines generally specify slightly lower pressures than sport bikes because their tires are designed for mixed surfaces and because the higher sidewall tires used on many ADV platforms function correctly at lower pressures. Front pressures typically in the 32 to 36 range, rear 36 to 42, depending on machine weight and load. Off-road specific riding, dirt tracks, gravel, and sand often benefits from reduced pressure below the street specification to increase the contact patch for traction on low grip surfaces. Everything in this video assumes you have an accurate gauge. That assumption is wrong for a significant proportion of riders. 3 different gauges measuring the same tire will frequently produce 3 different readings. Documented differences of 3 to 4 PSY between gauges measuring the same pressure are common. A rider who sets their pressure to 36 PSY using a gauge that reads 3 PSY high is actually running 33 PSY, meaningfully underinflated by any standard. The solution is calibration verification. Take your primary gauge and compare it against a known accurate reference. Most reputable tire shops will let you compare your gauge against a calibrated shop unit. If your gauge consistently reads high or low by a documented amount, adjust your target pressure accordingly. The experienced tech who spent $175 on a Motion Pro gauge for a calibration standard, then used it to verify his cheaper gauges, identified the correct approach. You do not need a $175 gauge for routine pressure checks. You need to know that the gauge you use every day reads accurately relative to a verified standard. Pencil gauges, the inexpensive clip-type gauges available for a few dollars, are documented to read within 1 PSY of calibrated reference gauges in controlled testing. Their accuracy is frequently better than their price suggests. Their failure modes are mechanical, a bent pin, a cracked barrel, a stuck release valve. Check a pencil gauge against a shop unit before trusting it as your primary reference. Digital gauges are more consistent between measurements, but are not necessarily more accurate than a good analog gauge. Their vulnerability is battery dependency. A digital gauge with a weak battery can read inconsistently without obvious warning. The gauge you use to check your pressure is only one of the service decisions that compounds across your tire's life. Section 7 of the 2026 Motorcycle Buyer's Bible has the complete maintenance schedule with the specific inspection items, tire pressure check frequency, tire age assessment, and wear pattern diagnosis, alongside the dealer rate versus DIY cost for every service item. The rider who checks their pressure cold before every ride and reads the chalk test result saves more per year in tire costs than the maintenance schedule costs to follow. Section 6 has the dealer scripts for when you are at a shop that recommends a service your owner's manual does not require. Link in the description. Was $97. Now $9. Every Schrader valve, the type of valve used on virtually every motorcycle tire, contains a small spring that seals the valve closed until a gauge or pump fitting compresses it. That spring is small. The force required to compress it is small. On a motorcycle tire valve, the valve stem typically protrudes perpendicular to the wheel rim, pointing outward, often roughly parallel to the ground, or pointing upward when the wheel is stationary. As the wheel rotates, the valve passes through the position where it is pointing directly downward. At that position, the centrifugal force of the rotating wheel is directed outward through the valve stem, and the mass of the valve core, small as it is, exerts a force on that spring in the direction that opens the valve. At normal street speeds, this centrifugal force is small enough to be negligible. At track speeds, or on machines capable of sustained high speeds, the centrifugal force at the valve can become sufficient to momentarily compress the valve spring, allowing small amounts of air to escape through the valve core with each rotation. The engineering solution is the same solution the road racing community has used for decades: a valve cap with an internal rubber gasket that provides a secondary seal against the valve face independent of the spring. Not a decorative cap, not an aluminum race-looking cap with no gasket. A rubber gasketed cap that seals the valve independently of the spring mechanism. This is not a theoretical concern constructed from physics. Race circuits do not allow motorcycles on track without gasketed valve caps, because the underpressure risk at track speeds is documented and real. The cost of rubber gasketed valve caps, less than $1 each. The cost of discovering your front tire has lost 3 psi at the end of a track day because you were running decorative aluminum caps with no gasket. The reset of your suspension setup and the uncertainty about every lap you ran with a degrading contact patch. When a tire shop mounts your motorcycle tire, they need a lubricant on the tire bead to seat it correctly against the rim. Most shops use whatever liquid lubricant is available, often dish soap or hand soap mixed with water. Most common soaps contain lye, sodium hydroxide, the chemical compound that gives soap its characteristic slippery feel. Lye is the natural chemical enemy of aluminum. It attacks aluminum surfaces through a slow oxidation process. When soap-based lubricant is used to seat a tire bead against an aluminum rim, which is the construction of most modern motorcycle wheels, the lye is trapped at the interface between the tire bead and the rim. It cannot be cleaned out after the tire is seated. It remains in contact with the aluminum wheel surface indefinitely, slowly corroding the rim at exactly the point where the air seal depends on a clean, smooth contact surface between the rubber bead and the aluminum. The documented consequence: a tire that develops a slow air leak, not through the valve, not through the tread, but past the bead seal where the lye has corroded the aluminum and prevented the clean seal the system requires. The rider who adds air every week and cannot find a puncture may have a bead seal that is slowly failing due to corrosion from the lubricant used when the tire was mounted. The correct mounting lubricant is rubber mounting paste or dedicated tire bead lubricant, available at any motorcycle parts supplier. If you are having tires mounted at a shop, you can ask what lubricant they use. A shop that uses soap-based lubricant on aluminum wheels is using incorrect procedure regardless of how long they have been doing it. The correct answer is rubber paste. The tires currently on your motorcycle have been recording every mile you have ridden since they were installed. The wear pattern they show is the most accurate record available of whether your pressure has been correct, whether your suspension is set appropriately, and whether your alignment is within specification. Run your bare hands slowly along the tread surface in both directions. This takes 30 seconds. The information it provides is irreplaceable. A smooth, even feel in both directions across the full tread width indicates correct inflation and appropriate riding for the tire's design. This is the result you want. A raised ridge at the center of the tread, higher when you run your hand toward the outside of the curve, indicates overinflation. The tire has been riding primarily on its center portion, wearing it faster than the edges. The edges retain tread that the center has already consumed. A rougher feel at the edges than at the center, or a scalloped, wavy texture at the edges, indicates underinflation combined with either aggressive cornering or suspension that is allowing the tire to bounce rather than maintain consistent road contact. A rippled or cupped feel anywhere across the tread surface, alternating raised and worn sections rather than smooth progression, indicates a balance or suspension problem rather than a pressure problem. Cupping is not correctable by adjusting pressure. It requires rebalancing and suspension inspection. One-sided wear, more wear on one edge of the tread than the other, on a straight-line rider indicates alignment. On a rider who consistently favors one direction in corners, it may indicate riding habits. Either way, pressure adjustment cannot correct asymmetric wear that has a mechanical cause. The wear pattern is free information. It is available every time you walk up to your motorcycle. Riders who read it regularly catch the pressure and maintenance problems that produce expensive tire failures before those failures occur. I drive a 2000 Ford Ranger with 340,000 miles on it, paid cash. I check the tire pressure before every drive in weather that can affect it. I know exactly what the tires feel like at correct pressure versus 3 psi low because I have paid enough attention across enough miles to have built that knowledge. Your motorcycle's 2 contact patches are the most important mechanical variables in your riding life. The swing arm number is where you start. Your owner's manual is the document that adds the load variables the tag cannot encode. The chalk test is how you verify the contact patch is correct rather than assuming it is. The cold check before the first ride is the only measurement that means anything. The gauge you use is only as accurate as the last time you verified it. The Pirelli Angel GT2 owner who ran 36 front and rear on his MT-09 SP and got 29,000 kilometers to the wear bars, without joke, he says, is the documented outcome of a rider who found the correct pressure for his machine and his riding and stayed consistent. That mileage is exceptional. It did not happen because he followed the swing arm number blindly. It happened because he found the number that worked and kept it there. Your tires are telling you whether your pressure is correct. The chalk marks on the pavement after a short ride are telling you. The wear pattern under your hand is telling you. The swing arm number is the beginning of the conversation, not the end of it.